So here is the example. Here we have 3 simultaneously. You can say the system of linear equation. Now here we have the value of a1, that is 1, the value of a2, that is 1, and the value of a3, that is 3. And this is basically m1, m2, and m3. So what we have to do is we have to check whether these are relatively prime or not. So if we check 5 GCD of 5 or 7, then the result is 1, and if I find the GCD of 7 and 11, then the result is 1. So that means these three numbers are relatively prime. So now we are going to apply the Chinese remainder theorem. So according to the Chinese remainder theorem, we discussed earlier that here we take x, that is equals to this one in modulo m, and m, that is basically the product of m1, m2, m3, and mi, that is equals to capital M over mi, and mi xi is congruent to 1 in modulo n. Now here is the question, and I am going to solve this by using the Chinese remainder theorem. So these three conditions, what we need here is we have to first find the value of m. So here the product of m1, m2, and m3, that is 5, 7, and 11, that is 385. So this is the value of the m. Now further is we have to check the value of mi, that is equals to capital M over mi. So I can write it as m1 over m1, that is equals to m over m1, that is the value of m is 5 into 7 into 11, and m1 is basically 5. So this 5 cancel with this 5, 7 into 11, that is 77. Now further is m2, that is m over m2, that is equals to 5 into 7 into 11 over 7, 7 cancel out, so the result is 55. So like this I have the value of m3. So these are the values of m1, m2, and m3. Now further is I am going to these three, I found the value of these three terms. Now find the value of this. So putting here the value of m1, so the value of m1 is 77, x1 is congruent to 1 in modulo m1, and the m1 is basically 5. So 77 x1 is congruent to 1 in modulo 5. So if I check this 77 in modulo 5, so that means we have the two remainder, because 75 is divided on 5, but here we have 77, so the remainder is 2. So 2 is the remainder here. So 2x1 is congruent to 1 in modulo 5. So what we have to do here is we multiply both sides with 3. I am multiplying here with 3 and with 3. So that means the result here is 6, and if I check 6 in modulo 5, so the result is 1. So x1 is congruent to 3 in modulo 5. This is basically the value of, you can say, the x1. Now further is putting the value in this term. So m2, the value of m2 is 55, x2 is congruent to 1 in modulo 7. So if I can check that 7 into 7, 49, so the remainder is 6. So 6x2 is congruent to 1 in modulo 7. Our motto is we have to place 1 here. So multiplying both sides with 6, so this is 36. x2 is congruent to 6 in modulo 7, and if I check 36 in modulo 7, so that is 35, and the remainder is 1. So x2 is congruent to 6 in modulo 7. Now further is m3, x3 is congruent to 1 in modulo 11. Putting the values and solving is, I found this result that x3 is congruent to 6 in modulo 11. So putting all these values here in this equation, so value of m1 is basically 77, the value of x1 is 3, and the value of a1 is 1. So putting all these values here, I have x equals to 77 into 3 into 1 plus 55 into 6 into 1 plus 35 into 6 into 3 in modulo 385. Now multiplying all these and adding, so I have x, that is equals to 1191. So if I check in modulo 385, the remainder is 36. The value of the x is 36 here. So this is the solution of this linear equation. So if I have some other example, as you can see here, if I have this example, so what we have, how to solve this example. So if I check this, that the you can say the GCD of 3 and 5, so that is, you can say 1, but the GCD of 6 and 3, that is 3. So that means these numbers are not relatively prime. So if I check with the Chinese remainder theorem, I can say that the modulo, I can say these numbers are basically are not piecewise relatively prime. So that means I cannot solve this question by the help of the Chinese theorem. So how to solve this question? I can use some other method to solve the system of linear equation.